Okay, now let's talk about net ionic equations. So far, when we've written our equation, we just write everything as a molecule or a formula unit, regardless of whether or not it would be soluble in water. Well, some things are soluble. And so if I combine them and they are still soluble, we're just going to get ions floating around in solution. So here I have some silver nitrate and some sodium chromate. Okay? Both of them, as you can see, are split up into ions in solution. So both of these are soluble. Now, when I combine them, I get that right there. I get some sort of a precipitate. But I also still have some ions in solution. So some of the stuff continues to float around in solution, while other stuff crashes out as a precipitate. So what our net ionic equations let us do is they let us break things down so that we can see exactly what reacted. So when I look at my silver nitrate and my sodium chromate, here is my molecular, also sometimes called my conventional equation. Okay, so you notice how everything stays together. That's intact, that's intact, that's intact, and that's intact. Okay, so everything stays together. Now, the first step is writing that. The second step is balancing it. The third step is writing what is called the total ionic equation. So in the total ionic equation, I'm going to go ahead and break up anything that needs to be broken up. So my silver nitrate salt and my sodium chromate salt are soluble. So they'll get broken up into ions like we did a few videos ago when we practiced just looking at, okay, if I've got a solution, what would these break up into? So we did that in our section 9.3. All right, so here are some compounds that split into ions. So my silver ion, and I have a coefficient of 2 in front of there, so I get 2 silver ions. Okay, I have a coefficient of 2 in front of this whole thing, so I get 2 nitrate ions. Now I've got the subscript of 2 for the sodium, which is why I have 2 sodiums. And then I only have 1 chromate. Okay, over here I have 2, so I have 2 sodium and 2 nitrate. And then what stays together, notice that the silver chromate is solid. So that stays together. That does not get broken up because it is an insoluble product. Okay? So when I look at this, my nitrate ion and my nitrate ion are still ions. My sodium ion and my sodium ions are still ions. So those are identical on both sides of the equation. So when I write my net ionic equation, I don't include those. I only put in my net ionic equation what actually reacted. And that's going to be my 2 silver ions, my chromate ion, and that solid silver chromate product. So again, our net ionic equations let us break things down and look at exactly what reacted in solution.